Hey y'all, my name is Deja White,
And I'm Elise Sanibel.
and today we're going to talk about sublimation, what the technique is used for. Sublimation is used for the separation of volatile components from non-volatile components, meaning it is a useful technique for the recovering of compounds that can be sublimed at valid temperatures, at either atmospheric or reduced pressure. Sublimation is the phase change from solid to gas. Sublimation is often referred to as the boiling process because it occurs when a compound's vapor pressure is equivalent to the atmospheric pressure. However, sublimation involves a solid's vapor pressure instead of a liquid's. There are four types of sublimation that are commonly used. Sublimation and erosion cause ablation, which is a process that erodes glaciers. Sublimation of iodine can be used to reveal fingerprints on paper. Sublimation is used to purify compounds, and sublimation of dry ice is used to produce fog effects. In the top right-hand corner, you can see the sublimation of ice to steam. In the bottom right-hand corner, you can see the formation of iodine crystals using sublimation.
How it works. Sublimation occurs when a compound's vapor pressure equals its applied pressure. Sublimation is rather uncommon because most solids do not have an appreciable vapor pressure at temperatures that are easily accessible. However, solids that can undergo sublimation generally have weak intermolecular forces. Sublimation can also be a good purification method if a volatile solid is contaminated with non-volatile impurities. Sublimation is also called a green chemistry technique because no solvents are used and no waste is generated in the process. The picture demonstrates what sublimation looks like in action. The most common example of a sublimation is dry ice and CO2. The CO2 goes directly from the solid phase to the gas phase with the addition of water, for example, which speeds up the reaction and causes that white eerie gas to form.
Procedures for atmospheric pressure. Step 1. Spread the dry solid to be sublimed on the bottom of the petri dish. Make sure you spread it enough so there is a thin layer as seen in picture A. Step 2. Make sure the solid is completely dry. If not, condensation may form, washing off the crystals from the dish on top. Step 3. Cover the petri dish, then place the petri dish on a wire mesh on top of a hot plate, as shown in picture B. Make sure you are conducting this part of the experiment under a fume hood. Step 4. Prepare a 600 milliliter beaker with ice water and place the beaker filled with ice water on top of the petri dish as shown in picture C. Step 5. Wait for the sample to begin sublimation. The sample will start to form on the top of the petri dish. If it starts turning black, then turn down the temperature. Sublimation is finished when no solid is left at the bottom. In the bottom right-hand pictures, you can see the process of sublimation occurring until all the crystals are at the top. Step 6. Remove the petri dish from the hot plate carefully. Use a heat-protectant glove to pick up the petri dish. Step 7. Separate the top and bottom of the petri dish and collect all the crystals that formed on the top. Then weigh out the pure crystals.
Vacuum sublimation procedures. Place the sample you are using in the bottom of an apparatus for sublimation. Use thick tubing to attach the vacuum arm and apply the vacuum. Make sure everything has a tight seal, as seen in the first picture. Run water through the condenser or a cold finger apparatus. Use a Bunsen burner, heat gun, or hot plate to heat the apparatus and the sample, as seen in the second picture. The reaction is complete when a solid appears to have formed around the cold finger, as seen in the third picture. Remove the coolant used and allow the apparatus to cool to room temperature. Slowly open the apparatus to release pressure without dispersing the crystals in the fourth picture. Remove the cold finger from the apparatus. These are our references.